Converting from rational functions, or converting rational functions from transformation form to quotient form. So remember that transformation form is the ax minus h plus k. So you're going to convert it from something like this to quotient form where it's all divided by, there's nothing adding or subtracting at the end. So it could be like, I don't know, let me try to find something. Like 2x plus 5 over x plus 4. So we're going to convert from this to this, and then there'll be a second video where we go backwards. So the first example is going to be if we have 1 over x minus 4 plus 1. So that's what we're going to convert from this form where there's a, h, and k to this form where it's all dividing. I can't just add this 1 here. And I know you guys hate adding and subtracting fractions, so I'm going to go over here and remind you of how to add and subtract. So reminder, if I have 1/2 and I add 2/5, I can't just say 1 plus 2 is 3. I can't say 2 plus 5 is 7. Remember, when we do this, we have to have a common denominator. So common denominator. So 2 and 5, you want to find the number that you can multiply both of those by, or each of those by, to get to the same thing. So we're going to get these to be over 10, because 2 times 5 gives you 10, and then 5 times 2 would give you 10 as well. So the step I'm doing right here is just to get a common denominator. Now, I can't just randomly multiply by a 5. You always have to multiply by 1. So whatever I multiply on the bottom, I have to multiply on the top. Whatever I multiply on the bottom, I have to multiply on the top. So 5 times 2 would be 10. 5 times 2 would be 10. 5 times 1 is 5. 2 times 2 is 4. And then 5 plus 4 is 9, so it would be 9/10 whenever I added that together. So that's getting a common denominator. You have to multiply. You will sometimes, I'm going to show you another way real quick. So if I do 1/2 plus 2/5, it's the same thing. If you multiply across the bottom, 2 times 5 is 10, and then multiply across. So 2 times 2, or I'm going to go this way first. 5 times 1 is 5, plus, and make sure you keep the plus sign, 2 times 2 is 4, which equals 9/10. So you're going to see me do it this way. I'm going to multiply across the bottom, and that's what goes there. And then I'm going to multiply crisscross and put the plus sign between them. And the reason this works, notice we did 2 times 2, which was 4, 2 times 2. It's just taking the denominator of this one and multiplying it over here, because that's what we multiplied by, 2 over 2 and 5 over 5. So that's where it came from. So when we do this example right here, if you notice, this is just a 1, so it's not a fraction. I'm going to put it over 1 just so that I can have the denominator. So I'm going to multiply across the bottom, which would be x minus 4, and then I'm going to multiply across. So 1 times 1 is 1, plus 1 times x minus 4, which is just 1x minus 4. Okay, distribute the 1. Well, we know 1 times anything is just anything, so it would be 1 plus x minus 4 over x minus 4. Then just combine like terms. So 1 and negative 4, 1 minus 4 is negative 3. So it'd be x minus 3 over x minus 4. So I multiply, and multiply. So that's where all of those numbers came from. And again, it's just multiplying by a common denominator. But I personally think that's the easiest way to do it, is to draw your multiply across the bottom and then cross multiply. So then our next example, if I have 3 over x minus 1 minus 2. That minus is kind of hard to see. Let me put a little bit of white out right there. So that's a minus 2. Okay, put it over 1. Then multiply across the bottom. 1 times x minus 1 is x minus 1. And then cross. So 3 times 1 is 3. Now notice this time it has a negative, so make sure instead of putting an addition sign between them, I'm going to put a subtraction sign. So then I do minus 2 times x minus 1. Remember, we put that parentheses to show I have to multiply this 2 times all of that information. Not all of it, but both parts. Then I'm going to distribute. Negative 2 times x is negative 2x. Negative 2 times negative 1 is positive 2, because a negative times a negative is positive. 2 times 1 is 2. And then we have 3 at the front. So 3 minus 2x plus 2 over x minus 1. Combine like terms. 3 plus 2 is 5. So your final answer would be negative 2x plus 5 divided by x minus 1. So this is quotient form, and this was the transformation. Okay, so now converting rationals from quotient form to transformation. Remember, that's where you have 2x plus 5, this is just an example, and x plus 4, and you're going to change it into a x minus h plus k. So now we're going the other direction. And the reason we do this is so that if you're given this and we tell you you're not allowed to use a calculator to find the transformation, which is very possible that you could see something like that, you need to know how to be able to divide this out to get the transformation form. So the way you're going to have to do this is you're going to be dividing. So you're going to divide. So if I have 3x plus 8 over x plus 2, you're going to have to divide that. So let me just remind you of division real quick. So reminder, just like I did on the last one. If I have 110 divided by 41, if I do 41 divided by 110, well, 41 times 1 would just be 41. I bet, and 40 times, and I'm just thinking of what numbers can go into 110, or what I can multiply 41 by to get 110, or get close without going over. So 40 times 2 would be 80. 40 times 3 would be 120. So we know it can't be 3. Even though this is just a little bit bigger than 40, I just use numbers that are close, easy numbers that are close. So 41 times 2 is probably going to do it. Let's see. 41 times 2. So 2 times 1 is 2. 2 times 4 is 8. So it would be 82. Yeah, that is probably it. So then remember, you do 2 times 41 is 82, and then subtract. 110 minus 82 10 minus 2 is 8. 10 minus 8 is 28. Okay, so when we have that, the way we write this is it's 2 plus, we had a remainder of 28, so you put the remainder on top over whatever you were dividing by. So that's how you write this, or that's a reminder of how you divide and write it as a mixed number or whatever. So now let's do this one. So it's been a while since we've divided using variables like this. So we have x plus 2 times 3x plus 8. Only one we care about is this first one. What times x gives you 3x? Well, 3 times x gives you 3x. So you're going to do 3 times x is 3x. 3 times 2 is 6. So 3 times x is 3x. 3 times 2 is 6. And then just like we did over here, you're going to subtract. 3x minus 3x cancels. 8 minus 6 is 2. So then we have 3 plus, we have 2 as our remainder, x plus 2. So you just take this number and put it on top. The only difference is, let me just go ahead and write this as a side note so you have it. So the remainder goes on top. Make sure that y'all can see that. Okay. And then remember, we need it in this form right here, a over x minus h plus k. So this plus 3 needs to actually be rewritten at the end. So you would do 2 over x plus 2 and then plus 3, where the 3 is at the end. So that's the final answer. Just because we want the k at the end, just like right there. We want the k at the end. Okay, next one. If we have 2x plus 7 over x minus 2, x minus 2 divided by 2x plus 7. Again, the only one we care about is the first two terms. So what times x gives you 2x? Well, 2 times x gives you 2x. So then now multiply. 2 times x is 2x. 2 times negative 2 is negative 4. Make sure you subtract both parts. So 2x minus 2x cancels. 7 minus negative 4. Make sure you see that that's minus negative 4. So 7 minus negative 4 is 11. Because when you subtract a negative, it's like you're adding. So 2 plus 11 is our remainder, so that's what goes on top, over x minus 2. Only thing you have to do here is rewrite it so the plus 2 is at the end. 11 over x minus 2 plus 2. So that is transformation, or from quotient to transformation form.